Hello and welcome back to the Linux Plus certification channel, where we help to get you Linux Plus certified. And we've got two more questions from my book, the Linux Plus certification all-in-one. This is from chapter 1 of the book, where we have several practice questions there, and I'll be going through these questions and showing why the answer is the answer. We'll do a demonstration here and there. If you like what you see, like, subscribe, hit the bell, and if you don't like what you see, hit the like button twice. So let's go ahead and go look at this first one. Which file keeps a list of intentionally untracked files that Git should ignore? We've got a.gitnot, b.gitnot, c.gitignore, d.git. I'll give you a moment to think about this, or you can pause this. And the answer to this one is c.gitignore. And the purpose of this file, let's take a quick look at Git. And I'll go to my Debian system, and we'll go ahead and initialize Git. And when you do a listing, you'll see that the -a, you'll see that the .git directory is created, and this file, or this directory rather, keeps track of all the settings of our Git conversation. And then, if we do a listing of this file, we can see that there information about the branches that we might be working on within Git, other hooks, and other information. In .gitignore, and I might have a README file that I want to be ignored. Maybe a phone directory that I want ignored. And I'll put all that inside a .gitignore. And when I do my pushes back to the main repository, those files will be ignored. So that's question number 23. .gitnot does not exist. Gitnot does not exist either. So those are both dodges, and then .git we spoke about is the directory that maintains the entire Git conversation. And the next question, command substitution, which allows a command to run within a command, is performed with which operators? And this should say choose two. So I'll give you a minute to think about this one, and you can pause here because the answer here is A and B. So that would be, let me show you how command substitution works. And so if we take a look here, I'll clear my screen here, and I'll say the date command is a good example. Say date, and it'll show us the date and time. Now if I say echo today is date, that's not going to run the date command. That's just going to show me date, the word. How do I get that command to run within the echo command? And so we can use the backtics to do it. The backticks are the key to the left of the one key. So if you look at your keyboard, look at the left of the one key, at least on the US keyboards. There's a backtick there right below the tilde. We could also, if you're using bash like I am, the born again shell, you can use $parentheses to perform the same function. And there we go. Now the other ones, the single quotes, as I show here, which are the keys to the left of the enter key on the US keyboard. The single quotes make all characters literal. So if I look at if I say echo and single quote, today is $date. Well, now all characters will be literal, so we'll just get today is $date. The double quotes make all literal except for backslash, dollar sign, and backtick, and oftentimes the exclamation mark. So we have a dollar sign there. So let's see what happens when we use the double quotes around this. And so now the double quotes make all literal except for this dollar sign. So now it's going to work just as if we didn't have the quotes around it at all. But if we had, let's take a look at the files we have. So we have some files to start with. M. If I said M star, we'll just see M star here. Versus if I didn't have the double quotes around it at all, then the M star would expand to these files here. And then let's take a look at this last one, the dollar curly braces. But what that would actually do, you would use that to work with variables. Let's do a clear here, glass. We'll set that equal to lens, and we'll hit enter, echo dollar glass. That'll show us lens. So what if I want to see echo dollar glasses? So I get lenses. Well, there's no glasses variable, so we get nothing. So what I can do is put curly braces around our variable. Now there is a variable called glass, so it finds lens and replaces that with lenses. So the curly braces will go ahead and tighten that variable and say, here, this is the variable we want. We have a couple more questions coming up. Feel free to stop back shortly for a couple more questions from our book here on Linux Plus certification. We'll see you at our next video.